Well, hi there, boys and girls. Today we are going to look at the derivative of e to the u. The derivative of e to the u, and where u is some function of x. And so we're going to start with the basic e to the u. We're going to start with y equals e to the x. And I'm going to ask you, is this derivative equal to x times e to the x minus 1? And of course, you're going to say, no, Mr. G, this only works if this up here is a real number and this is a polynomial. E to the x is not a polynomial. It's called a transcendental function. So this is not a true statement. So you may not do this. No, no, no. Bad math student. So let's take a look at what the derivative is. Now what I'm going to do is I'm going to start by taking the natural log of both sides, because I know the derivative of natural log and we're going to find it that way. Of course we know that with natural log this x can come down in front, so I'm going to do that first. The natural log of y is equal to x times the natural log of e. And everybody knows that the natural log of e is equal to 1. Therefore, this means we just have the natural log of y is equal to x. Now what I'm going to do now is I'm going to take the derivative of both sides. I'm going to ddx both sides. ddx everything. Now the derivative of natural log of y is y prime over y. You guys know that. Remember, u prime over u. And the derivative with respect to x of x is just 1. Cross multiply and you get that y prime is equal to y. And this is a very, very cool statement. This means that e to the x is its own derivative. You can take the derivative of e to the x and you get e to the x. That's pretty much the easiest derivative of all time. So, you don't do anything to it. The derivative of e to the x is just e to the x. In other words, a geometric application of this is that the slope of e to the x is equal to the y coordinate at that point. What do you mean, Mr. G? Well, if I were to take the graph of e to the x, e to the x crosses at 0, 1, and then just goes up like this, like any exponential function. And let's say you want the slope out here at 3. The y coordinate would be equal to e to the third, because we're on e to the x. Guess what the slope is? The slope is e cubed. Y prime equals y. That's pretty neat. The only other thing you need to know is that the derivative of e to the u is equal to e to the u, but then we have to use, guess what? It starts with c and ends in hane. Chain rule. So we have to multiply this times the derivative of u. So let's do some examples and get done with this business. If y equals e to the x squared minus 3x, then y prime equals, well, it's e to the x squared minus 3x. I don't know where that random dot came from, but we're getting rid of it like it never happened. Then we multiply that times the derivative of the exponent, 2x minus 3, because of the chain rule. So this will be a, man, that was really tough. I'm being sarcastic. I really like the derivative of e to the x. Oh my goodness, e to the 1 over x. Well, here you have u equals 1 over x, which is equal to x to the negative 1. So what does u prime equal? U prime is negative x to the negative 2, which is negative 1 over x squared. So the derivative of e to the 1 over x is e to the 1 over x, and then times negative 1 over x squared, because that's the derivative of the exponent. It's the chain rule. Looks like we've got a here. Third one. A curve is defined by y equals e to the sine 2x, find dy dx. Well, here if u equals sine of 2x, then u prime is 2 cosine of 2x. So the derivative is going to be e to the sine 2x times this business right here, because that's the u prime, times that. So it's e to the sine of 2x times 2 cosine of 2x. It looks like we have it right here. Okay, last question. Oh my gosh, there's a 2 on the bottom. I don't know what to do. I'm going to raise my hand and ask Mr. G what to do here. And for the 15th time, I will tell you that if you have a number, this is like a constant 1/2, take the number out in front of the derivative and call this 1/2 times e to the x minus e to the negative x. Don't freak out, just take the number out there. Then we're going to take the derivative of this. So the 1/2 is just going to sit there. Then I'm going to take the derivative of the inside parentheses. The derivative of e to the x is e to the x. Now the derivative of e to the negative x would be e to the negative x, but then times the derivative of the exponent. Times -1, I'll just turn that negative positive. There we have it, 1/2 e to the x plus e to the negative x. It's right there, number D. See you guys tomorrow. Deuces.